Okay, here we continue the midterm review with the questions 11 through 20. So question 11, you have x minus 10 square root of x plus 21, very similar to the one we just did. And what we want to do is perhaps use substitution where u is equal to square root of 10. So we have x squared, which in this case is going to actually be u squared, my apologies. U squared minus 10u plus 21 equal to 0. So this obviously has to be two numbers that multiply to give you 21 but add to give you negative 10. So I'm thinking u minus 3 times u minus 7, obviously equal to 0. I'm sorry, u is equal to square root of x. That's just a little moment. All right, so given that information, once we have this factored, we want to come back and substitute, right? So we're going to now say square root of x is minus 3 is equal to 0, and therefore square root of x is equal to 3, and x, if I square both sides, remember we're squaring both sides. That means that x is equal to 9. That's one of our possible solutions. Our other possible solution is if I substitute in square root of x for u, minus 7 equal to 0, that means that square root of x is going to be equal to 7. So if I square both sides, I get x is equal to 49. All right, so now we have to check. So if I have 9 as an answer in this case, then I would have 9 minus 10 times the square root of 9 plus 21 should equal 0. So we start checking. We're checking here. So square root of 9 is 3, so you basically have 9 minus 30 plus 21. Is that equal to 0? Yes or no? And we could see that obviously that is going to give us 30 minus 30. So the 9 is definitely one of our solutions. Now we have to check the second part of the equation. So we're going to use the 49 at this point. So 49 minus 10 times square root of 49 plus 21, is that equal to 0? So this gives us 49, and this is negative 10 times 7, so you get negative 70 plus 21, is that equal to 0? And so in this case, our solution set should be both of them. It should be A for 11, 49 and 9. Both do work. Question number 12. Question number 12 is yet another one where u substitution comes in very handy. So if I have 7x to the negative 2 plus 8x to the negative 1 plus 1, and this is equal to 0, and I use u substitution, again, remember I'm always focused in the center term. So that means that u is equal to x to the negative 1. So that means that in this case, this is 7u squared plus 8u plus 1 is equal to 0. And so looking at our solutions, if I factor this out, setting it to 0, this would have to be a 7u times a 1u, and obviously a plus 1 and a plus 1. If I check the inner-outer products, notice that that does give you the positive 8u. This does give you a 1, and this does give you 7u squared. So in this case, if I take 7u and I substitute in that x negative 1, so what I have is 7 times x to the negative 1 plus 1 equal to 0. I'll start checking with this one. So that means that 7x to the negative 1 is equal to negative 1. If I divide by 7 on both sides, I'm left with x to the negative 1 is equal to negative 1 over 7. Remember, we don't like negative exponents, so if we literally take this and we could do one of two things. If I just reverse these values, notice that our answer here is going to actually be x equal to -7. So that's your first value, because you end up using the reciprocal. Okay, the reason why the reciprocal is because of the -1 exponent. Okay, in our second answer, we have x to the -1, plus 1 is equal to 0. So therefore, x to the -1 is equal to -1. So therefore, once again, you flip it around. This actually becomes x equals -1. Doesn't really matter or change in this case. So number 12 should be answer choice B. Okay, same thing for number 13. Number 13, we have more of the same. We have x to the 2 over 3 power minus 2x to the 1 over 3 power minus 3 is equal to 0. Once again, I'm paying attention to the center term for u substitution. That means that u is equal to x to the 1/3. So therefore, this is u squared minus 2u minus 3 equal to 0. And if I factor this out, I'm going to get, in this case, let's see. I'm going to get, I think this will be a u minus 3 times a u plus 1. And now we bring back our cubic, x to the 1/3. So that means that x to the 1/3 minus 3 is equal to 0. Therefore, x to the 1/3 is really equal to 3. I'm going to raise both sides to the 3 over 1, which means that x is equal to 27. That's one of my answers. I'm going to repeat this process with the u plus 1, so I'll substitute in our value. Let me make some room here. I'm going to erase this for a minute. So here we have x to the 1/3 plus 1 equal to 0, which means you have x to the 1/3 is equal to -1. Once again, if I take this and I raise it to the 3 over 1 power on both sides, I get x is equal to -1. So our solution for number 13 should be answer choice A, where your two solutions are -1 and 27, which I originally had here. I had x equals 27. All right, and that should be answer choice A. I don't know why the pen does that. All right, and number 14, let's take a look at number 14. We have x minus 3 squared plus 7 times x minus 3 plus 12 equals 0. All right, so plus 12 equals 0. So I'm going to obviously use u substitution, where u is equal to x minus 3. So this becomes u squared plus 7u plus 12 equal to 0. And now we factor, and I'm thinking that this should be a u plus 3 times a u plus 4 equal to 0. And if I substitute in for my u, because remember this u is actually x minus 3, I'll have x minus 3 plus 3 times x minus 3 plus 4. Obviously, both of those equal to 0. And notice that you end up canceling here, because I'll end up with x minus 3 plus 3 equal to 0. Therefore, x is equal to 0. And over here, I end up with x minus 3 plus 4, which is x plus 1, equal to 0. So for this one, number 14, it looks like our answer choice is going to be 0 and -1. Because once I move the 1, this will be a -1 sitting here. So that looks like that's going to be answer choice D for number 14. Here's number 15. On number 15, we have the absolute value of 2 parentheses x plus 1 plus 4, and this equals 8. So if I solve for this inside part first, which is what I should be doing first, I end up with the absolute value of 2x plus 2 plus 4, and this is equal to 8. And therefore this is the absolute value of 2x plus 6 equal to 8. Now we balance it. If you remember, I said to you simply use the opposite sign on the opposite side. So if I subtract 6 on both sides, notice that I get negative 14 is equal to 2x is equal to 2. And now I divide by 2 on both sides, all 3 sides. This will cancel. This divides to give me negative 7 is equal to x is equal to 1. So the solution for 14 should be negative 7 and 1. You can always go back and check. If you plug in the values, you'll notice that this actually works out. So always check, because remember, it's a FAR. It's one of those FAR equations. In this case, absolute value. All right, let's look at number 16. It says use graphs to find the set. And they give us negative infinity, comma 3, intersection, that's the overlap. That's the overlap, that's the crisscross, what I call the crisscross. Remember when I said blue and yellow make green? That's the intersection. Okay, so in this case, what I want to do is I want to draw a number line. Okay, remember inclusive, not inclusive, that does matter. And the symbol, I don't know what's going on with the pen. You notice that? Oh, you know what it is? It's the power cord. Let me get the power back on here. That's usually my telltale. Hey, you're running out of power. The pen's going to start acting funny. All right, here we go. Back to connection. It's nice and quiet in here, thank God. I'm able to record. This is awesome. Remember, always write out negative infinity, positive infinity for your own sanity. So you have a negative 6 sitting out here, and this is inclusive. So I'll draw a nice big bracket there. I've got a positive 3. So this is going from negative infinity to positive 3. So let's say this is positive 3. It is not inclusive, so that's a parentheses. So I'm going to draw the negative infinity, positive 3 like this. That's this part here, just to remind you. And I've got a 12, positive 12 sitting out here. That's too far. It's going to confuse you. Let's put the 12 here. And remember, this is a number line. And it's from negative 6 to 12. Let me use blue. It should be giving me a nice little shimmy here. Remember, this is not inclusive. Where does it overlap? Where is both happening? And it's as simple as both is happening from negative 6 inclusive, comma, to 3 not inclusive. So when we look at 16, we're looking at our answer choice that matches the same graph. And so you'll see that answer choice D is the correct answers for that one. All right, let's look at 17. More drawing. So for number 17, we have negative 5, comma 0, not inclusive, intersection, inclusive, negative 4, comma 7, inclusive. So we want to draw a number line again. Remember, negative infinity on the left, positive infinity on the right, 0 right smack in the middle, not inclusive, Negative 5 sitting somewhere over here, not inclusive. So we have right now this interval. Intersection, and once again, so we're looking at the overlap. Here's negative 4, inclusive. Notice that's a bracket. To positive 7, inclusive. So once again, let's do color code. The 5, 0, I'll do in yellow. 5 to 0, that's yellow. All right, fine. Negative 4 to 7, that's blue. So negative 4 all the way to 7. Again, I'm looking for overlap. Where do they intersect? So if you look carefully, you'll see the intersection of yellow and blue is happening in the section between negative 4 inclusive, comma 0 not inclusive. So if you look at 17, looks like your answer choice should be C. All right. Let's look at answer choice 18, or answer 18, question 18. You have 5, comma infinity. Not intersection, this is union. This is inclusive of 12 all the way to positive infinity again. So on number 18, this should be fairly easy. If it's inclusive, or excuse me, this is union, everything gets taken. If you remember the example I gave you, I was being comical when I said, once you get married, nothing is yours, everything is ours. Right, here's a 12. So, yeah, I thought that was a negative. I don't know why I thought that was a negative. Here's a 12. And this is going on infinitely inclusive of 12. So here's the overlap. Again, 5 to infinity, that's all of that. Okay, this is 12, comma infinity. Okay, notice that I'm using the same color code because it's union. It's everything that's put together anyway. So there is no overlap. It's everything. So if I take those, this answer should be 5 non-inclusive, comma infinity non-inclusive. Your answer for number 18 should be A. All right, number 19. Let me see if I can fit 19 and 20 on here. I should be able to. Okay, number 19. You have a lot of math to do here, and I'm concerned about the order of operations. So let's make sure we have this down pat. So we have x minus 2 over 12 greater than or equal to x minus 5 over 18 plus 1 over 36. Okay, a little mental math. I know that 18 times 2 is equal to 36. I also know that 12 times 3 is equal to 36. So it looks like my LCM is 36. So I'm going to multiply the entire equation by 36 on both sides. Technically all the way across. So I really don't even have to do this on both sides. Just know that you're doing this on both sides. All right, with that said, the denominators cancel out with the numerators now. 12 goes into 36 3 times, so this becomes 3 times x minus 2 is greater than or equal to 18 goes into 36 at least twice, so that's 2 times x minus 5, and obviously plus 1 because 36 goes into 36 one time, so 1 times 1. All right, now you have a simple equation to solve. This gives you 3x minus 6 is greater than or equal to 2x minus 10 plus 1. So now I have 3x minus 6 is greater than or equal to 2x minus 9. If I move the 2x, I'll subtract the 2x over here and here. I'm going to add the 6 to both sides. This leaves me with x is greater than or equal to negative 3. Notice that I subtracted a negative 2x. It's okay. You can subtract that all day long. So that means that if I have a 3 sitting here, remember this is negative infinity, positive infinity. Again, x is greater than or equal to negative 3. So here's negative 3. It is inclusive, so a bracket. And I'm filling this in all the way through, all the way to positive infinity, because I'm looking at numbers that are bigger than negative 3. So let's look at these diagrams carefully. I'm going to open this up a little bit now that you know what it should look like. And let's see. I'm going to have to stretch this out a little bit. Definitely not A. Definitely not B, because that's not inclusive. I'm looking for a bracket. So it's definitely not B either. And it's got to be D. So if you notice, that is what we got, which was inclusive of negative 3, comma, infinity. Not inclusive. All right. Excellent. All right, number 20. Actually, I'm going to do number 20 in the second video. So let me stop this here.